Hi, I wanted to talk a little bit, give a little quick lesson on how to determine if a number is prime or not. So, a prime number, just to get the definition out of the way, is a number that is only divisible by 1 and itself. For example, 6. If you list all the multiplication facts sort of that could make 6 with only whole numbers, so numbers that aren't decimals, you could do 1 times 6, and you could also do 2 times 3. Because 1 times 6 is not a problem in terms of 6 being prime. Every number is that. No matter what number it is, you can always write 1 times that number, and you'll get that number. That doesn't make something not prime. But this 2 times 3 does make it not prime. There's other numbers. So in a way, 6 is made of other numbers when we're talking about in terms of multiplication. It's made of 2 and 3. You can make a 6 with a 2 and a 3. So one quick little note. I was always told in my elementary school and even maybe in middle school math that there's like a debate over whether 1 is prime or not. It's not prime. The first prime number is 2. And 2 is also the only even prime number. Every other even number has a 2 in it. So therefore that number is not prime. Every other number that's even can be written as 2 times something. So 2 is the first prime number. I'm going to list a few others. 3, 5, 7, 11, 13, 17. Okay, that's as far as we'll go for now. We'll keep that in a little box up there. It's going to be handy for later. So let's see. So how do we figure out if a number is prime? Well, one thing is we could just ask ourselves, does it have any factors, and go through each factor and check. But there's a faster way, and I wanted to get at that. So let's look at the number 36. Now I'm going to tell you right off the top, 36 is not prime, but I picked it because it's a square. It's a square and it has a lot of factors. It'll help with what we want to do here. So 36 could be made by 1 and 36, could be made by 2 and 18, could be made by 3 and 9. Look at all these factors. This is maybe the least prime number ever. 3 and 9, that's crazy. 3 and 12, 4 and 9, and then 6 and 6. I want you to notice something. So little fun fact here. Square root of 36, can't write anything today. Square root of 36 is 6. So also negative 6, but we don't care about negatives for this discussion. Notice how these factors of 36 pair off. 1, 36, 2, 18, 3, 12, 4, 9, 6, 6. There's a lower one and a higher one, and then when you get to the square root, they're the same. That's the idea of a square root. So it turns out actually that if you run up, say we got something like 25, and we want to figure out whether it's prime. I'm going to show you another trick that shortens what you have to do. But for now, as we're running through the numbers, we check 2. 2? No, it's not 2 because you look at the 5. It ends with a 5, not 3. I'll go through how to figure out if something is divisible by 3, but it's not. 3. 4, we'll talk about why we don't really need to check 4 in a bit, but it's not a multiple of 4. 5. Oh, it is. Okay, so 25 isn't prime. Okay, we can stop at 5. Imagine 5 hadn't been there. The next number we would have checked is 6. But 5 is the square root of 25. So if 6 or some other number were going to be a factor, we would have already come across its pairing on the low end. 6 would be kind of the high end. So that'd be like 36. If we were going along, we got, when we found out 4, right? Suppose we missed 4. Suppose we missed 2, 3, 4, and 6. We get to 9, we say, 36 is a multiple of, 36 has 9 as a factor. we would have to realize 9 is bigger than the square root. We must have missed something because there has to be something lower than the square root in order for the two numbers to multiply together to make 36. So we only have to go up to the square root. So if ever you're checking a number to see whether it's prime, you only have to go up to its square root and really not its real square root. So for example, like 101. The square root of 100 is 10, and the square root of 11 squared is 121. So 101 doesn't really have 11 in it. So since we're only dealing with whole numbers, 10 would have to kind of be the highest factor it could have. You couldn't get, say, 11 times 11 would be too high. So if there was like a 13 in 101, there'd have to be something lower than 11, but also the only thing lower than 11 that's a whole number is 10 or lower. So we only have to check up to like 10 for 101. That could be tedious though, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, it turns out actually you only have to check the primes because think about it. So suppose I check 2. Is it a multiple of 2? Well, most people will be able to see it's not, right? You look at it ends in a 1. It's an odd number. It's not a multiple of 2. Now, do I have to check 4? No, I don't, because I know that if 101 had a 4 in it, if it was 4 times something, it would also be 2 times something, and I've already eliminated that. So I can eliminate all the multiples of 2. Anything that has a multiple of 2, that is a multiple of 2, also can't be a factor of 101. It turns out that if you carry this logic to its end, right? So suppose I check 3 now for 101. Suppose I carry this logic to its end. That means that any multiple of 3 can't be, if 3 turns out to not be a factor, which it isn't. Anything with a 3 in it, like say 6, that also would not be possible as a factor, because if it had a 6 in it, it would have a 3 in it. So you only have to check the primes. So actually for 101, in order to check whether it has any multiples at all on the whole number line, we only have to check 2, 3, 5, and 7. Only 4 numbers. We've checked 2. We'll talk about how we check the other ones. I'll just say 3 is not, 5 you can see isn't. 7 is a little trickier, but let's see. We got, yeah, I know 7 times 13 is 91. That's a good fact to know. 91 is 10 different than 101. So if you add 7, you're going to be 3 short. It's not going to go in even. So it turns out actually 101 is a prime number. We can know that by only checking 4 numbers. So let's take a look at some other numbers quickly and a few more examples. So for example, 37. I'll make our little bank of lower prime numbers. 2, 3, 5, 7, 11, 13. That should be enough. So 37. So first I would ask myself maybe, what's the square root of 37? Well, 37 is a little more than 36, so we only have to go up to 6. 6 is somewhere between 5 and 7, so we only have to check 2, 3, and 5. Well, 2 is out. 36 is a multiple of 3. That's one way to know. I'll do another video on multiple tricks. But 3 is out, and 5 is out. So we see 37 is prime. Prime numbers are really awesome. If you think of it, they're the building blocks of the number line. And that'll come. You'll learn more about that maybe later in math if you're in middle school right now. But if you think about numbers, primes are really fascinating. So hopefully this was helpful, and we'll see you next time.